Warm up for lesson 6-1. Pause to do the problem. And here's the answer. Now recognize that when the calculator gives you this, it's a scientific notation, and that means this, which is really 0. So our x value is going to be 0. Pause. Now, greatest common factor should be taken out before you go any further. Pause. Hopefully you recognize this is a quad form, which I could go ahead and factor, and then I can use my square root property to go ahead and find the answers. This is a 4th degree polynomial, so you should have 4 answers. Pause. And here are the answers. I took my P over Q and I wrote all my combinations, and nowhere in the numerator is there a 4. Pause. And here are the answers. And again, nowhere in the numerator do I have a 4. So I'm not going to be able to have that as a 0. Lesson 6-1, operations on functions. Objective, find the sum, difference, product, and quotient of functions. Find the composition of functions. Okay, so we're really going to make new functions from old ones. And in this case, the first thing we're going to do is just perform arithmetic operations. So arithmetic operations like addition, subtraction, multiplication, and division. So this is going to be the notation that says we're going to add the two functions together. So in this example, we're going to take f of x, we're going to take that function, and then we're going to take g of x, we're going to add them together and then simplify. And we'll do the same thing with subtracting and with multiplying and with dividing. All right, let's take a look at another example. Here we are adding, and adding means to just add the two functions. So we're taking this and we're writing it here. We're taking this and we're writing it here, and we complete the addition. Now in subtraction, you just have to be careful, because when you subtract, don't forget to distribute the negative sign through here before you go ahead and do that. All right, let me do a problem from scratch. And so this is f of x plus g of x. So f of x is x squared plus 5x minus 2. G of x is 3x minus 2. Combine like terms, x squared plus 8x minus 4. And this is our new function. Over here, this means f of x minus g of x. And f of x is x squared minus 4. Now we're going to subtract. Don't forget to put a parenthesis so you can remember to distribute. And then this will be x squared minus 4 minus 2x minus 1. And that simplifies to x squared minus 2x minus 5. And again, this is our new function made by subtracting two old functions. Let's go ahead and take a minute to take a look at this same thing with our graphing calculator. And you notice that I went ahead and I put x squared minus 4 and 2x plus 1 there. And let's go ahead and look at the graph of both of them. Now we should be seeing a parabola, and we should be seeing a line. And what we want to do is we want to add those to create a new function. So I'm going to go back to y equals, and you can see I added them up together. I'm going to go over here and I'm going to turn this off. I'm going to turn this off, and then I'm going to turn on the brand new function, and you can see it has a square in it, so you should expect to see a parabola again. It's in a different location, but it's still a parabola. All right, and let's go ahead and take a look at our next screen. Okay, new function from old. So let's again examine this idea of adding here, and I want you to see that I'll go ahead and write it out here. F of f plus g of x means f of x plus g of x. We're taking this y value and we're adding it to another y value. And so that's what these are. These are y values for f, and y values for g, and when you add them up, they'll give you a brand new, this is our new y values here, and that's why the parabola changes its position there. And we can do it again with subtraction as well. Okay, let's pause and see if you can do some adding, and don't forget to simplify. And here's the answer. Okay, attempt to do some subtracting to create your new function. And here's the answer. All right, let's go ahead and take a look at multiplying and dividing functions, but we do have to remember that under division, that when you have a term in the denominator is not allowed to equal 0. So we're going to have some restrictions there. So here's our f times g of x, and we can write it this way. And here's my f, and I'm going to go ahead and write it here. And my g, I'm going to write it here, and then I'm going to multiply by distributing. Okay, in division, it's f of x over g of x, and again, I'm putting my f in the numerator, my g in the denominator, and remember, the denominator is not allowed to equal 0, so 3x is not allowed to equal 4, and x is not allowed to be 4/3. So this must be part of the answer you give me. All right, let's go ahead and practice where I start from scratch. And this is equal to f of x times g of x. And that means x squared minus 7x plus 2 times x plus 4. And I'm going to distribute the x first, x cubed minus 7x squared plus 2x. Now I'm going to distribute the 4, plus 4x squared minus 28x plus 8. Combine like terms, and that's okay, and so there's the answer. Now let's take a look at b, which means f of x all over g of x. Our f of x is x squared minus 7x plus 2, and our denominator is x plus 4. But you can't stop here, because you've got to give me the restriction. We know that the restriction is x plus 4 cannot equal 0, so x cannot equal negative 4. And you have to put this as part of your answer. This is telling us that there's a restriction on our domain. Pause, and you try the problem. And here's the answer. Pause. And here's the answer. Okay, let's go to another type of operation to make a new function, and that's called a composition of function. So what we're going to do is we're going to put one function inside another function. So we're taking x and sending the output of g into f. So this now is going to be what we're sending in right here. We're going to send g of x into f, and then we'll get this brand new function here, f of g of x. This is not multiplication. Okay, so let's go ahead and show you. A lot of students call this fog. It's not multiplication. It actually is f of g of x. So a lot of times I will just say f of g of x instead of saying this. I'll say, oh, that's f of g of x. Okay, so what we're doing is I'm going to first, here's your first step, first outline f. So f is right here. You can see it's 3, put a parentheses in for x squared, minus, put a parentheses in for your x plus 4. So we've created the f function, and what we're going to do is we're going to put g of x everywhere we see an x. So I'm going to put 2x minus 1, because that's what g of x is. It's 2x minus 1, and then 2x minus 1. And I don't know why I wrote that step. So let me go ahead and erase it, because I've already done this part here. Okay, so now I'm ready to just simplify. So this is going to be 3 times 2x minus 1 times 2x minus 1. And then I'm going to distribute minus 2x plus 1 plus 4. Okay, and now I'm going to multiply. I'm going to use FOIL, 4x squared. And my outer is negative 2x. My inner is negative 2x, so I'll just say negative 4x. And my last are plus 1. Okay, and now I'm going to distribute 12x squared minus 12x plus 3 minus 2x, and I'm going to call this a 5. So this is 12x squared minus 14x, and then this is plus 8. And this is a simplified version. This is our brand new function created by putting g of x into f. Now let's go ahead and find this, g of f of x, g of f of x. So we're going to put this inside of g. So I take g and I outline it by putting parentheses everywhere there's an x. And then inside the parentheses, I am going to write what f of x is, which is 3x squared minus x plus 4. Okay, now I'm going to distribute, and so this is 6x squared minus 2x plus 8 minus 1. And this is 6x squared minus 2x plus 7. And this is our brand new function. Now notice that they're not the same. Notice that when you put g inside of f, it's not the same as putting f inside of g. Okay, I know this is still new, so I'm still going to continue to do a problem. We want to find f of g of x. So I'm going to do that first. I'm going to write f of g of x. And I'm going to take my f function, which is right here. And everywhere there's an x, I'm going to write parentheses. Okay, and then I'm going to put g of x inside, and this is what g of x is. It is x plus 5. Okay, and now I'm going to multiply out, so this is going to be x squared plus 10x plus 25 plus 2x plus 10 plus 3. So this is x squared plus 12x, and then this is plus 38. Now, when I already graphed it right here, this is what I have here, and the question says, what is the domain? Well, we know that the domain is all real numbers, and the range for this is going to be, it looks like right here, it's going to be greater than 2. All right, so both A and C have, oops, I don't think it's A, because this is our function right here, so it can't be A. And we know this is our answer here, and we know this is our range. They didn't get the range right here, so we know that the B part isn't right. So we know the answer is C, but I'm going to go ahead and demonstrate g of f of x. Okay, so I'm going to go to my g, I'm going to put a parentheses everywhere there's an x plus 5, and then I'm going to put f inside. So that's going to be x squared plus 2x plus 3. And then when I simplify, that's going to be x squared plus 2x, and then that's going to be a plus 8, which I already have figured out right here. And I graphed it, and when I graphed it, the range is greater than 7. So this really is the answer. All right, composition of functions. We saw this slide before, and I just want to reiterate. So we're taking this, we're taking g of x, and we're making g of x our domain of our f. So it's going to go inside f, and that's going to happen. Okay, please pause and see who's doing it correctly and who isn't. And here's the answer. It looks like Tobias substituted for each x, where Chris only substituted for the x squared but forgot about doing that.